So for those of you that don't know me, I'm Dr. Brady Goettl. So I took over Dr. Dave Franzen's position, who was Extension Soil Fertility for about 31 years. So I did my PhD work under Dr. Franzen and then was able to move into his position after he retired. So I've been around NDSU about 5 years now, working in previously a research role and then now moving into extension. So first of all, I just want to cover a little bit about what's new in North Dakota soil science. So in addition to the retirement of Dr. Franzen, he's still around helping out with some extension things in between catching pretty good sized catfish on the Red River. We have a lot of new faces on main campus and at all of the RECs. So we've kind of broke records in extension this year with 17 new hires at various specialist positions, and quite a few of those are in soil science. So on main campus in Fargo, we have a new soil microbiologist that's looking at climate smart agriculture in the realm of soils. So with all of this buzzwords around climate smart and carbon capture, that's the type of stuff that he's working on, along with more traditional fertility, soil science, agronomy positions at some of the RECs. We've updated quite a few publications. So as Dr. Franzen was retiring, he took that time to update as many of the circulars as he could. I've also put a few together in my time there. So if you're on the NDSU website, you'll see a lot of updates. Make sure you, especially for the fertility related things I'll talk about later, go with the updated recommendations because those are really tailored to the latest research that we've been doing. We've released several phone apps, computer apps as well for fertility management. I'll talk about that in a little bit too. And what's new in soil science, some new and emerging problems. So some of these are things that we faced in the past, we have continued to face, but they're changing and morphing a little bit, like I'll talk about. And then also some up and coming fertility issues that I think we should look at now to try to be able to nip those in the bud as they become bigger issues. So looking at the publications, here's just a sampling of some of the updated ones that have had strong changes to them, some of them more minor, some of them major changes. I don't know, are these going to be available after the presentation? Okay, perfect. So if this presentation is available, all of the links should work. So if you have this presentation, you can click on it, it'll take you to the PDF version. But the major things that have changed, managing salinity, saline soils in North Dakota, that publication has been updated and is available, along with land judging, compatibility of North Dakota soil for irrigations, as well as that have been updated with some changes. And as the NRCS and MLRA soil surveys changed a little bit, that's been updated for some different soil type names, or some soil types have been combined. And then lastly, and most importantly, North Dakota fertilizer recommendation tables and equations. That's the big fertility guide. There's been some pretty major changes in there. So if you're still using the paper recommendations, make sure you get that updated with the newest version. Something a little new and exciting, there's been some big changes to our app and our desktop calculators. So the sunflower, corn, wheat now has the malting barley end calculator included in it as well. If you have the old nitrogen app, you'll have to delete that one and then reload the new one from your respective app store in order to get those updates. It won't automatically update for the newest version. And then also just came out about 3 months ago is the gypsum calculator. So that's really catered towards the reclamation folks, or if you have difficult saline soda areas in your field, you can put in what your soil test results are and give you a gypsum recommendation. So that was put together between myself, Dave Franzen, and then Tom Besutter on main campus. All of these are also available for desktop versions, excuse me. So if you go to these links here, those will also have links to either the app version or the computer version if you choose to do it on your desktop. Here's just an example of what the calculator looks like. This would be from the desktop version. So those of you that have used this in the past, it should look familiar. Just inputs in case this one is with malting barley. It's based on that bushel price, nitrogen costs. We also have a few different soil parameters that are included as well, including organic matter, 2-foot nitrate soil test. This is really important for our work. is that the 2-foot nitrate sample is taken. And then lastly, some credits and then a little bit of information on the part of the state you're in, because there's kind of a sliding scale depending where you're at in the state. So a few fertility points to remember before we start getting into some of the details. Like I mentioned about the nitrate, the only way to know our fertility is to sample. I work with several folks throughout the state that are running into some major fertility issues that kind of snuck up on them. A lot of them I'll talk about later. And that all stems from soil samples weren't taken on that field in about 8 years. So trying to make recommendations off of those old sampling points just obviously wasn't working. And I think, like I'll talk about here in a little bit, some of these problems we're going to have to try to head off at the pass a little bit. Also, a reminder that our end recommendations are based on economics, not on yield. If you're trying to grow a crop to maximum yield, you're going to have to fertilize a little bit higher than what our recommendations are. Now, in my mind, we're all trying to grow a crop to max economics. We want to make the most money. That's how our recommendations are built. So those fertility levels might be a little bit lower than what you've seen in the past where the goal was growing yield. We'll talk about this here more in a little bit. Additionally, take the credits you have coming. So both legume credits, no-till credit also, make sure those are counted into, especially on the nitrogen side of things, into that final recommendation. So all of our nitrogen fertilizer recommendations aren't total N to be applied as fertilizer, rather total known available N. And what that means is simply adding together those crop credits that I just talked about, tillage credits as well. So if you're in a no-till system, you can get an additional nitrogen credit. If you're in a conventional till system, then the recommendation is as it stands. Making sure that 2-foot nitrate sample is taken. Yeah, I'll talk a little bit at the end about, looking forward to spring a little bit, but I think this might be a year to think about potentially if you had some fall nitrate samples taken. We had quite a bit of moisture and all that after there might be a little bit of movement in those nitrate samples. So potentially sampling in the spring, if you expect that you've had some nitrogen losses, might be a good way to dial in those recommendations a bit tighter. And then lastly, to balance out that total known available N, is that nitrogen is added fertilizer. So when we have that final recommendation number, subtract all those off, what you're left with is what you want to put on as nitrogen. So the reason we've had to go with the total known available N, the reason that we're approaching our recommendations from that economic perspective, not only for nitrogen, but also as phosphorus in certain crops, is we're trying to go away from this yield goal approach. Now, this was used for a lot of years, for the majority of the last century, by all major land grants as their way of developing fertility recommendations. And it attempted to relate yield, so whether it be bushels of corn, bushels of wheat, directly to N. So this is where that old adage, 1.2, pounds of N per bushel, or depending on where you were. Later on, we also started to bring in different N sources, some of those different credits. And at the end of the day, what the equation would look like is we'd have that nitrogen that we'd add as fertilizer, minus whatever credits we had, and then that simple yield goal calculation, whether it be 1.2 or 1, or whatever you had. Now, unfortunately, even though it was simple to calculate that, it really didn't give us a great predictor of yield. So this chart is simply showing grain yield, bushels per acre. This is malting barley. So this is data that we collected about 2 years ago up by Gardner, so just north of Fargo. And then our total known available nitrogen. As you can see, here was kind of a good year with good moisture. We had what we'd expect, where yield keeps going up till a certain point it starts to plateau. Here was another year that it was just a little too dry. And we were basing those yield goal calculations off of data that looked like this, kind of a shocking class. And at the end of the day, it just really didn't work very well. We'd be over fertilizing, we'd be under fertilizing, and it'd be costing us money, which should make us all sad if we're not, economically putting on fertilizer. Oh, so why, we knew that this existed since we started using the yield goal calculation. But why did it last as long as it did? Why is it still popular? Really, it comes down to it's easy. Okay, even though it really kind of had that weak relationship, we had to try to predict yield at the time of fertilization. So you know, if I could shake my magic 8 ball or look at my crystal ball and I knew how much yield we'd get at the end of the season and what the season would be like, these yield goals work really well, but we're trying to predict things that can't necessarily do. And it also ignored field to field variation. So we moved then to this relative yield approach. And really what that attempted to do and does is standardize yield within each environment. So what that means is when we're figuring out what our recommendations are, we're putting plots across the state of wheat and corn and soybeans, doing all of our nutrients. And within each of those sites, we're calling it an environment. And each environment acts a little bit differently as far as yield in response to nitrogen. So if we set them all together equally, compare apples to apples, we can do that by dividing the maximum yield at each of those test sites by 1. So essentially that takes out bushels per acre, pounds per acre out of the yield. And we're just saying with X amount of nitrogen or phosphorus, we're getting 100% yield at the site. And all other yields below that in our research is just a percent of whatever that maximum is. And then when we combine all of those sites together, they're equal regardless of actual yield. Now, this is the exact same data that I showed earlier with the frowny face, except it's all set on a relative basis. And now that predictor line that we'll use for our recommendations looks a lot better. All of the sites are behaving quite similar regardless of what the weather conditions were or what other factors that are compounding it. So then when we can take that and this wasn't just occurring in the barley research that we've done, but this has been proven across all kinds of different crops in different areas across the state. So this column here shows like the raw yield regression line. So the number in that is just how well this fits. So 100% would mean every single dot would land on that line. So in the case of, Durham and the Western region, if we just looked at bushels of Durham compared to nitrogen, our fit would be very, very poor. So 0.16% we're predicted by that. If we go with that standardized yield, we're predicting now 50% or higher. So this goes to show that we're able to predict our fertility a lot better using this approach. So the question always comes up, well, if you're combining all these sites, there's going to be variation. Okay, so if we have a low yield environment, whether too droughty or clayey or a too whatever you want to say in this field, it's going to have a lower nitrogen use efficiency. We're going to have to apply more fertilizer per bushel in order to reach whatever that maximum productivity is. And that's due to less mineralization, denitrification, whatever's occurring in those fields. Now, on the other side of the spectrum, we have a high yield environment. So whatever is good that particular year, whether it's good fertility and the other aspects that we're not looking at, for nitrogen, for example, good soil texture, ideal moisture, we're going to have higher nitrogen use efficiency, greater N mineralization. So now if we go and start thinking about that yield goal approach again, we still just have one number, regardless of what these yield environments were. So with what your one number is, you're not going to be applying enough fertilizer for those low ones and potentially too much for these high ones. So regardless of environment, based on the economic relative yield approach, the rate to produce that maximum yield is similar when we set them relative to each other. Doing that relative approach also lets us take it a step farther to start looking at economics as well. So if we have, for example, easy numbers of $1 per pound of nitrogen, which is way too high, or $6 per bushel barley, we're looking at 124 pound fertilizer. Now this is again a total known available nitrogen rate. We need to subtract some credits off of that in order for it to work. Now the question always comes up, why would we want to not fertilize maximum? So using that same example I've been carrying through here, if we have that 124 pounds of nitrogen per acre, so this was the economic yield, we're going to be at the top of that net return curve, which is simply our gross return. So whatever our dollars per bushel are. So as we continue fertilizing, we start to plateau off. We know this, if you start getting too high N rates, especially in barley, as in this example, we'll start to turn down our yield lodging. So you simply can think of this as kind of that yield curve. The difference then is the fertilizer cost. So as we apply more fertilizer, it's going to continue going up in price at a linear rate. So then net return is just the difference between these two. So our economic maximum rate is going to be at the top of that net return curve. If our goal is to hit maximum yield up here, now we're actually down on that net return. So we're making less money by growing more yield. And, I grew up on a farm. I run a cash crop operation on the side. I'm interested in making more money. And what's nice about this is as the environmental interests become more strong, that there's more interest in reducing nitrogen application, we can do that and still make more money on it. This is really working in the best interest of people that want us to reduce nitrogen fertilizer and us as a farmer. By reducing it, we can make more money as well. So thinking about these numbers a little bit, the 186 pounds at maximum yield fertilizer rate, our net return to nitrogen is about $173 per acre. Obviously, this is basing everything off of having to buy all the nitrogen, which we're not doing because we need to count in the credits as well. And this doesn't bring in all of the other costs. So these numbers are a little bit better just for comparison purposes than they are actual on field return. And then at that, I see I made a mistake. That should be 125. We're at about $200 per acre of return. Remember, subtracting those credits as well is going to put us in most cases 40 to 50 pounds of added nitrogen in this bar that you see. So let's start talking about some of the problems that we saw last season and what is going to continue to be an issue. I received a lot of phone calls that started out, my beans are turning yellow. What do I do? We dig into that a little bit. But what I noticed was a lot of these reports were from East and Central North Dakota. Was it IDC? Was it disease? Was it something else? The answer to that question is yes. The first biggest problem we saw, and it's going to continue to be an issue, is iron deficiency chlorosis. We're going to see it expand as soybean acres expand as well. And I think it's important to understand what we can and can't do about IDC. So we know it occurs in these calcareous high pH soils, which for those of you that caught Dr. Hoffman's presentation this morning, we're blessed with in North Dakota. It's commonly noted in spring. What was interesting this year is it showed up a little bit later in the season. That's what threw a lot of people off. Was the beans started out really strong. We kind of got past that point. We typically see IDC, and then it started setting in late June. And the reason for that was all of the exasperating situations. So we had wet soils during that time period, which drives up the chances of IDC. We had fairly high nitrate, that wet soil, that in certain cases it was a little bit warm after application of nitrogen. So we had a lot of nitrate swimming around in those fields. And then lastly, the high IDC. So we've had those salts moving around in ways that aren't favorable to us the last few years, all driving up those chances for IDC. So here's an example of a field that we got that picture from. Again, this was from a couple of years ago. This year, we're seeing IDC on plants that were quite a bit larger. That's awesome. I'm going to glaze through some of this because most of you know why IDC happens in the first place, but what can we actually do about it? So it really comes back to field selection. So our ideal fields to plant soybeans on, which in a lot of cases we can't necessarily do anything about, but keeping in mind, if we have a field that's lower in carbonates or that has slightly acid soils, so that's less than that 7.2 pH, the chances of having IDC are significantly less. So that means we probably don't have to do other things in order to prevent it from happening, because very truly in IDC, an ounce of prevention is worth a pound of cure. Looking at fields that have lower EC, and then something that we can do something about is move towards more favorable drainage. So as soybeans start becoming grown more prevalently, it's going to become more important to make sure that has favorable drainage in order to prevent IDC, which can significantly reduce yield. Lastly, a great tool is looking at those NDSU soybean variety trials and choosing those cultivars that have higher IDC resistance. Some of the other things, so if we're in a field that does have high carbonate, that does have IDC, that is not favorably drained, then looking at some of these other options in order to prevent IDC will likely pay off. The most commonly talked about one is adding that chelated iron. Soy green, for an example, would be a trade name of that. In furrow has shown a good way to reduce IDC, but remember, this isn't a silver bullet either. So stacking some of these other things. Increasing planting density, so some work done by Dr. Goose, the IDC guru of the world, essentially, showed that if you're in 15-inch rows or greater, so getting those plants a little bit closer together can actually help to reduce IDC. Obviously, that opens the door for some other challenges, but by having those roots of the plants a little bit more intermingled, can help decrease that prevalence of IDC occurring by the plants actually helping each other take up that iron that the other way would be able to due to the way the roots are exuding certain substances. And then lastly, looking at using a spring nurse crop or cover crop. Chandler coming up after me, I think is going to be talking a little bit about cover crops and the way they take up water. And that's really the goal of this system is in a wet year, if you plant an oat nurse crop with those soybeans, we can reduce the water in that field, reduce the chances of IDC occurring. And again, there's no silver bullet to this. So this is a conversation I had a lot of times this spring is just doing one thing likely isn't going to solve. So this is another picture taken up in Griggs County. Does anybody recognize those deficiency symptoms? Anybody got an idea? There you go. Do we normally see it at this side of soybean though? And do we normally see it at the top of the plant? No, that's why it was really strange. So this is a potassium deficiency, but it showed up very strangely in the plant. And what this came down to was, this is a long-term no-till field that hasn't received any K fertilizer in at least 8 years. So that stratification that we're worried about was occurring early in the season, and I'll show you in pictures a little bit later, was so what occurred in this field was, as the combine is going across, it was spreading the residue out. It wasn't necessarily making it all the way to the outside area. So we can see these darker stripes that follows exactly where the combine was driven with the same size header for the last 8 years, long-term no-till and no K fertilizer. So the residue from behind the combine would fall right where these darker rows are. That would break down and provide enough K to these soybean plants to get them up and on the ground. Now, these areas where they're light, the residue wasn't reaching. The plants were severely depleting the K. No residue was falling on that area to break down and give it a little chance. So in the upper area where there was a little bit of root residue that was breaking down, it'd get out of the ground, not have a K deficiency, but as that is depleted in the upper layer, the roots start growing deeper. They ran out of potassium and you start seeing plates. So this is a really unique situation. We don't know why exactly it occurs in the new leaves and not in the old leaves like the traditional. There's been a lot of work in Iowa State trying to crack this nut. So far, they haven't been successful at it. So we know it happens. We don't know why. And diagnosing things like this is really best done then with that nutrient tissue test. So we can make recommendations off of the tissue test very well, but it's a really good way to diagnose these issues. So in this case, potassium levels in the plant were 0.33%. We should be in that 1.7 to 2.5. So obviously there's a severe deficiency occurring in those plants. Here's a soil test from that field. We were down at 77 parts per million. Incredibly low based on that critical level that we have in North Dakota. Also another thing to look at, and again, a direct result of not having that history of K fertilizer, is our chloride was down to about 1 pound per acre. Recommended levels of K, 150 to 200 parts per million. And what we mean by critical level is anything below that, we're likely going to have some gluten. If you're at or above that critical level, then we're getting closer to maximizing that plant's potential. And then that chloride critical level, about 40 pounds per acre. So this is a major problem from a yield standpoint, but something that could simply be solved by potash application. And the reason this is becoming more of an issue is a lot of parts of the state, we historically haven't had to apply any potash. We have enough in preparing fertility to keep all those K levels high enough. But so when we start thinking about the crops that we used to grow, wheat, for example, has a fairly low removal rate when we're only taking the grain. As more soybeans are starting to be grown, as corn is starting to be grown, as canola, we've been growing it now for about 30 years. We've really driven down those inherent fertility levels. And now we're starting to see those efficiencies that we haven't before. So we're kind of at a breaking point in some parts of the state where we're going to have to look at applying more fertilizer than we've had in the past for some of these nutrients. And again, the best way to do this is to make sure you soil sample. Let's only put on as much as we need, try to spread that out over multiple years, try to reduce that economic impact of those applications. So what awaits us in 2025? I'm not an economist and I can't read the future. I can only go off of what economists and people attempting to read the future tell us. And it really comes down to it depends. So that's both for weather and for fertilizer prices. Looking at the precipitation outlook, this comes from the National Weather Service and NOAA. Going all the way through April, we're at about an equal chance for precipitation, which unfortunately isn't going to solve some of the problems in western North Dakota that are still in severe drought. That part of the state would really like to see above average precipitation. Unfortunately, none of the models are really predicting that. We kind of have equal chances for both. Temperature outlook, unfortunately, we're below average all the way through March. Really not going to have a lot of impact on crop, obviously at this time, but it's going to make us a little bit more sad if we're going to be below average cold. Going into spring, looking at some of those weather forecasts and what we had in the fall, we're going to expect some end losses. So a lot of end fertilizer was going on this past fall. It was really as long, drawn out, but all the way until about mid-November, the soil was really too warm, to be putting on N. A lot of it was happening just because conditions were good. Unfortunately, due to that, we should expect some losses from that. So potentially having to supplement N in the spring, definitely going to want a nitrate sample to try to put a little bit more of a peg on what we have left. In corn, potentially doing a top dress or a side dress to correct any of those issues from lost N. Like I talked about before, K deficiencies is appearing to become more common in some areas of the state. For those people that have had a long history of soil sampling, they should be pretty well on top of this. With fields that haven't been soil sampled or don't have a good cadence of sampling, definitely talking to those producers about this kind of thing is going to become quite important. And unfortunately, we're probably going to see pretty widespread erosion occurring again going into spring. A lot of fall tillage was done. Again, the conditions were good. Unfortunately, this freezing, thawing, kind of wet conditions, bare conditions we have this winter has really opened up the doors for some potential erosion occurring once that soil starts to thaw out, just because that freeze thaw has broken down a lot of those big floods that we had going into winter. Fertilizer outlook. This information comes from about 3 different sources, both nationally and internationally. And the only thing that they can all agree on is the prices are mixed and the outlook is pretty cloudy. And a lot of these issues don't necessarily come from supply, but it's definitely on the political side of things that's causing this cloudy outlook. When we think about the sources of a lot of our fertilizer, it's not domestic production. So we're sourcing a lot of our phosphate from Africa. All of the majority of our potash in this area is coming out of Canada. With the upcoming administration that's talking about putting tariffs on some of these folks, that's definitely going to impact our fertilizer prices. How much? We don't know. Does it necessarily mean they're going to go up? No, but there's a chance that it could happen. What fertilizers are going to be most impacted? Well, right now, as we sit from the report that I got 3 days ago, urea and UAN is currently down for the majority of the United States, and we don't expect it to move a whole lot going forward, based on reports that I've seen. So, any of the fertilizers that are impacted by any type of, political trade type things, urea is not expected to be impacted that way. MAP and DAP are currently holding steady. This is expected to increase, mostly due again to that increase in market volatility. And there's some issues right now with supply. So some of the countries that are producing it aren't producing as much, and that's causing some of that price to go up potentially. And then if trade issues start happening, MAP and DAP are likely to spike. Potash, and good news is we're down quite a bit from last year nationwide. There's currently a good supply, so Canada is sitting on a lot of potash right now. There's good stockpiles of it right now in the States. So as of a couple days ago, we're averaging in the Northern Plains about 315 to 330 a ton, down from about 400 a ton last year. Hopefully the prices stay stable. As long as we keep the Canadians happy, the prices shouldn't spike. But remember, I'm not an economist. These are all guesstimates based on all the reports that I've been reading. So don't come hunting me down and potash all of a sudden moves. Plug for the upcoming soil water workshop in Fargo. So there was a handout that could have come around. Perfect. So the one side of that handout has some QR codes for the updated recommendations that I talked about. The other side of that is some more information on the soil water workshop. So that's January 22nd at the Fargo Dome. Additionally, we have a virtual option. It'll be an opportunity to get about 5.5 CEU credits in nutrient management in soil and water. Yeah, more. Send them around. Please register online by January 13th. There is a $100 registration fee to pay for the venue, and it will include lunch and snacks throughout the day as well. So we'll be covering topics. I'll dig a little bit more into that K issue. We'll have some folks talking about pH, updated our phosphorus recommendations for soybeans, so that'll be in there as well. So anybody interested in that, definitely check out the soil water workshop. With that, thanks for your time.